Hello. So this is a continuation of the last video, and here we're gonna take a very quick episode to have some examples on the quasi-concave utilities and concave utilities. Okay, so continued from the previous one, and we said that the convex purposes it can only imply quasi-concave utilities. Okay, and the definition of that is set here. Okay, it is written here. However, here in the second paragraph, we said that, however, the convexity of the preference relation, it doesn't imply a stronger called concavity or concave utility function. Okay, so here we can transfer or we can have example to further illustrate those two definitions. One is quasi-concavity and the other is concavity of utilities. Okay, and this will be very helpful for us to further understand the differences. So let's have a look on the on those three little pictures that we have in the three-dimensional real space, positive real space for different utility functions. Okay, and regarding x1, x2, two different commodities. So right in the middle, so this would be a utility which is concave. Okay, so this orange or this red line is a line that let's suppose that this is the line that connects all those intersections with the 45-degree rays crossing or intersecting all those indifference curves. Okay, and here this orange line, it is concave. Okay, and this utility function here, it would be concave, and it satisfies the conditions or the requirement that or the definitions that we just mentioned. Okay, and here, no matter where, okay, in the other two pictures, we can see that no matter whether this orange line, okay, this ray or this line, this curve, this orange curve, no matter it is straight on the third little picture, or it is concave in the second one, or even it is convex in the first one, it doesn't matter. It doesn't affect the fact that this upper contour set is convex. Okay, so the upper contour set of all those blue curves, right? So those blue curves are just indifferent curves, right? So the upper contour sets of those blue curves, they're all convex, right? As we can see here, they're all convex. And no matter whether this orange curve, it is convex in the first one, or it is concave in the second one, or it is straight, is linear, it is both convex and concave, it is linear in the third one, it doesn't matter, right? This won't affect the upper contour set to be convex. Okay, so that's why we said that this is all those are the possible cases in quasi-concave utilities. And here we can directly see the reason that with this convex preferences we cannot derive a concave exactly the second picture here, right? It doesn't apply this, but it could apply in general. It is a quasi-concave utility function, and it can be any of those three different cases. Okay, and I hope this will be a useful example to illustrate the idea or the differences between the quasi-concave utilities and concave utilities. And this is also another example for us to demonstrate the three-dimensional space to represent the utility function regarding the two commodities in this case. Okay. All right. So here we only have those rays, those orange curves, to be the rays connecting those intersections of the difference curves. But since this is just it is not easy to just to depict those full pictures with hands, but you could always search or find some useful references or some pictures to see in a full shapes of the three-dimensional utility functions. What do those functions look like? Okay, so here this will be a simple illustration, and hopefully this will be useful for us to understand this further. Okay, good.